Welcome to Brunda Engineering Academy. In this video, we will continue the second part of the properties of the materials. That subject is belongs to the both strength of materials and engineering materials. In the previous video, we stopped here up to the toughness property we discussed today. The ability of the material to absorb energy up to the fracture during the plastic deformation is called as the toughness, and that toughness depends upon the strength and ductility. Okay, now the continuation of that property here, the ability of the material to absorb the energy. How much amount of energy absorbed by that material? That amount of energy, the amount of energy absorbed in stressing a material up to the elastic limit, is called as the resilience. That means this is not a property, this is the quantity of energy absorbed by the body, the amount of energy absorbed by the body up to the elastic limit. This energy per unit volume is called as the modulus of resilience. That means here the energy absorbed by the body is the amount of energy absorbed by the body is the resilience, and that energy per unit volume, the absorbed energy per unit volume is called as the modulus of resilience. Modulus of resilience is nothing but the amount of energy absorbed by per unit volume. Amount of energy absorbed per unit volume is the modulus of resilience. It is belongs to the toughness property of that material. After that, in some of the examples, some loads are acting suddenly on any body, Okay, that the resistance to the shock loads or sudden loads is called as the impact of strength. Impact means the resistance to the shock loads or sudden loads is called as the impact of strength. That means suppose a body we can apply it at indeterminate of time. That means if you observe at the speed breaker, suddenly we are having if you travel on a bike, then if you are having the speed breaker, then it will give some shock loads to our bike. Like that, some examples are there. The resistance to shock loads, are sudden loads is called as the impact of strength. This can be calculated by using energy required for fracturing the specimen of unit cross-sectional area. That is nothing but impact strength can be represented by the letter I. That can be energy required to fracture the specimen per unit area. Impact strength can be calculated by using the relation. Impact strength can be calculated by using energy per unit area. Energy per unit area, in this energy means energy required to fracture the specimen. Energy having the units of joules, area having the units of meter square. So it is having the units of joule per meter square. And next property is brittleness. Brittleness means the property of sudden fracture, without having any visible permanent deformation. That means that deformation cannot be visible to our naked eye. Okay, but there is some deformation that cannot be observed by the human eye, but the fracture will be suddenly happens. The property of sudden fracture without any visible permanent deformation is called as the brittleness for the material. Next, hardness. To this hardness, I will consider an example. Suppose if you consider any body, any object, on that object, I consider a hammer. With the help of hammer, I strikes on that body. on that object. Then, due to that pressure or due to that load on that body, some indentation will be act. Indentation is nothing but the mark. Indentation is nothing but the mark will be acting. Some mark will be, if the sudden load will be happens on the body, if the load will be happens on the body, some mark representing will be acting on that body. So that property is called as the hardness. As the definition point of view, the resistance of a metal to the indentation or deformation is called as the hardness of that material. Okay. Next, creep. Creep is nothing but the slow and progressive deformation. Slow and progressive deformation of the material with the time at a constant stress. Suppose I consider an object like this. On this, I am applying 100 newtons of force, 1,000 newtons of force. The force is common. That is nothing but the stress is the common. Stress is the common constant. Stress is the constant. 100 newtons force will be applied. With the time, suppose I am applying 1 hour time, 1 hour duration, 2 hours duration, and 24 hours duration. Okay. So in the entire day, that 1,000 newtons will be acting on the body. Then due to this time progression, that body will be deforms. That body will be deforms. That body will be deforms like this. That body will be deforms like this. After 24 hours, the body will be deforms like this. After 48 hours, the body may be again compressed together, but the load will be the constant. The time will be varies. That means the deformation will be in the slow and progressive. Progressive is nothing but the uniform deformation. Slow and progressive deformation of the material with the time at constant stress is called as the creep. To prevent that creep at a high temperature, that property is called as the creep resistance. The ability of material to resist the creep, is called as the creep resistance. Is called as the creep resistance. Next, after that, fatigue. Fatigue is nothing but failure of the material. Fatigue means failure of the material under repeated or reversal stresses. Repeated or reversal stresses. Suppose a compound wall is there. I want to dismantle this compound wall. Now I am applying the force with the help of the hammer. With the help of the hammer repeatedly, repeatedly, we are applying the same force or different forces at some particular point. That then that material will be damages. That means failure of the material under repeated or reversal stresses. Failure of the material under repeated or reversal stresses is called as the fatigue. Fatigue. Next, one more component. Now it is not a property. One parameter, that is a fatigue limit or endurance limit. Fatigue limit or endurance limit. Fatigue limit or endurance limit means maximum stress at which the material will operate indefinitely without failure. Here we are applying the number of reversible forces or repeated forces on the body. How much amount up to the failure we are applying. Before the failure, how much amount of stress will be applied on that material. That limit is called as the fatigue limit or endurance limit. That limit is called as the fatigue limit or endurance limit. And one more important concept is nothing but one important point, that fatigue limit or endurance limit is less than the ultimate strength of the material. Ultimate strength of the material. Endurance limit of a material is much less than the ultimate strength of the material. So these are the important mechanical properties of the materials. This concept can be used for the both subjects, strength of materials and engineering materials for the mechanical engineering students, whereas this topic can be used in the strength of materials for the civil engineering students. In the next video, in the examination point of view, in the competitive examination point of view, how the questions will be asked. Okay, that will be discussed there. So if you like this video, please like and share and subscribe. Thank you, Brunda.